Welcome back. Let us go through the question. What is the excess pressure inside a bubble of a soap solution of radius 5 mm given that the surface tension of soap solution at the temperature 20 degree is 2.5 into 10 to the power minus 2 Newton per meter? If an air bubble of the same dimension were formed at depth of 40 centimeter inside a container containing the soap solution of relative density 1.2, what would be the pressure inside the bubble? 1 atmospheric pressure is 1.01 into 10 to the power 5 Pascal. Excess pressure inside a bubble given by delta P equals 4 capital T divided by small r. It's double the usual value because of the presence of two layers in case of soap bubble, where capital T is surface tension and small r is the radius of the bubble. Now delta P equals 4 into 2.5 into 10 to the power minus 2 divided by 5 into 10 to the power minus 3. So the delta P is 20 Pascal. And the atmospheric pressure is 1.01 into 10 to the power minus 5 Pascal. The density of soap solution is rho s, which is equal to 1.2 into 10 to the power 3 kg per meter cube. Now the pressure at the depth of 40 centimeter in the soap solution is Pa plus rho s gh. Now if we put in these values, this is coming out to be 1.057 into 10 to the power 5 Pascal. Total pressure inside the air bubble at that depth is this, given by this formula, which is Pt equals Ps plus 2 capital T divided by R. If we put in these values, we eventually get the value to be equal to 1.0571 into 10 to the power 5 Pascal.